Hi, sir.
Hi. So how's it going in school?
They said they will have a test on September 21st.
Okay. So how many chapters, like per subject?
Three, actually, other subjects they told us that we'll have three, but
Okay.
officially we haven't heard anything from chemistry.
Okay.
She's just saying study everything, study everything. So
Study
we don't
everything. So
know
how
the
they
official
have,
subjects for the first test.
they would have completed some basic concepts, atomic structure,
So
periodic
today
table.
in our class, she told that study till redox reaction, like the
Okay.
first
So
5 chapters, which
first five chapters that includes chemical bonding, redox, atomic structure, periodic table, and some basic concepts.
and
Right.
yes, sir.
Okay. Okay.
But she was
Pretty much.
not sure, sir. I
hmm
don't know.
But for preparing five chapters, September 25th. Doable, but again, like some quality time has to be spent, right? So what I would suggest is, see, seriously, like if you want to like say prepare quickly, right, say for a chapter, for a test or something, like you have the say the what to say, the advantage of viewing the recorded videos. We know all the recorded videos, whatever I take are actually recorded, isn't it? So somehow if you can just like, obviously I'll not be, sometimes I'll be asking questions, I'll be giving you time for also solving the questions, so all those things you can cut, right? And then you can actually watch the videos just before, like say like you can but chemical bonding as such, if you take, you'll have so many videos to look at. But yeah, that is one of the ways by which you'll be able to cover something very quickly, right? Okay, so now have they finished redox in your school?
Yes, sir.
So they have started now gaseous state, or like this, or is that states of matter?
Sir, they're just literally running, sir.
Running. Okay. Hmm. Right. Cool. Like anyways, like we will finish it. Like now after this, thermodynamics would be a little big chapter, and then again equilibrium will be a big chapter. All the upcoming chapters are little big. This chapter, gaseous state, is actually a little small, right? But after that, thermodynamics, equilibrium, and then your organic comes, gentle organic chemistry, hydrocarbons. All these four chapters are actually pretty big, right? And after that, we have to go for inorganic. That is your like study periodic table, right? So now we'll go in depth with the periodic table, study elements like in depth in the group wise. Say I'll be studying group 1, group 2, group 13, and group 14. Like that, I'll study in depth in 11th class. And when I go to 12th class, I'll be studying all the other groups, D and F block elements, the P block elements. All these things we'll be studying in depth again, like in 12th class. So all these are other remaining chapters. So that's why I told you, right? You should be ready that sometimes, or say some from September last week, or say October first week, I might ask you to come a little early to the class, say 6:30 to 8 or something like that. And most of you said it's okay, right? So, but not now, right? Anyways, it will happen only in October first week, something like that, right? So hope everybody has joined.
Sir, can you again say what you want, teacher? I learned, I can join very late, sir. Today new lesson, sir.
Oh, nothing. You didn't miss anything. I didn't start the class. We were just discussing like what are the remaining chapters, like what is happening in school. Like they I have a test like on.
Okay, sir. So today new lesson, sir.
Anyway, so we were speaking about those things.
Sir, your voice is feeble, sir.
Sorry.
Sir, your voice is feeble, sir.
My voice is. Like now, is it okay? Like
Yes, sir. No, okay, sir. Sir, you want to start new lesson, sir?
no. Already we started, right? Gaseous state, right?
Then
Last
okay,
class.
sir. Okay, sir.
Okay, so guys, do you remember what and all we spoke last class? Like I gave you an introduction about. We went back to your ninth standard, like went into that matter in our surroundings chapter. Like I told
Sir,
you
you
what
ended
matter
in
is.
temperature, sir.
Correct, right? So we saw, and like what to say. Then we saw what matter is, what are the matter is made up of, And then I spoke about particles, their three main properties, that is intermolecular space, intermolecular force, and kinetic energy. And by that, I'll be able to classify matter into three types: solid, liquids, and gases. And we saw how are these three parameters existing in these three states of matter, right? And then we said we're going to speak only about gases, liquids to some extent, because liquids will be covered majority in your physics, right? And then solids will be studying in your 12th class, right? Okay. So and then what we spoke, and then we spoke about gases. We said that there are going to be certain measurable parameters, very important parameters for a gas if you want to study about the gas, right? So those three are basically going to be pressure, volume, and temperature. Actually, other than these three, you can include one more measurable parameters also, which is important, which is your number of moles, right? Obviously, the amount of that particular gas is also important. How much is there? Okay, so then we went on to see what is pressure, how pressure is, like say, exerted by the gas, right? We said that there are going to be, like, since my gas molecules have high kinetic energy, right? They are among all the three states. The gas molecules have high kinetic energy, maximum kinetic energy. So they'll be in continuous random motions, or they'll be undergoing some type of collisions, not some types, specifically two types of collision, right? So between them, like basically between two gas molecules, or say the gas molecule can go and hit the walls of the container. So obviously there'll be some force with which it will bombard with the walls of the container, and obviously there'll be some area of contact, right? So that small force dF by the small area dA, the small dF by dA, and then if I take into account of all the molecules, all the collisions, right, with the walls of the container, right, I'll be ending up with the total pressure of the gas, that is P is equal to F by A, right? And then we went on to see what are all the different units of pressure. You tell me, what is the SI unit of pressure, people? What is the SI unit of pressure?
Pascal.
Pascal. Or
Newton by meter square.
exactly, right? It's force by area. I know force, SI unit of force is Newton, right? Area is meter squared, so it's Newton per meter squared. Okay. What are all the other units of pressure we discussed, people? Like, what are the other units? What were the other than the SI unit? What are all the other units?
Like ATM and bar, sir.
Okay, ATM and bar.
Then we saw Tor also, sir.
Tor.
Then we saw even mm of Hg.
Yes. So these are all the different units of pressure, right? Okay. So then we saw what are the conversions. How do you convert from one unit of pressure to another one, right? So approximately I can say that 1 ATM is 1 bar. Actually, 1 ATM will be 1.013 bar, like, but yeah, we can like say approximately say that 1 ATM is 1 bar, right? Okay, so this then we actually spent some time on this millimeters of mercury, if you can remember, right? So we studied something about manometers, right? So I told you an experiment which can conduct. Say I have a tube full of mercury, and then I have a vessel full of mercury, right? Say if I just invert it, without making sure that nothing spills, right? So I'll be able to measure the pressure, but not in terms of ATM or bar, but in a new unit called as mm of Hg. Like we relate that with this equation. Like, okay, I'll ask you, what is that equation which relates pressure and height?
P equal to rho GH.
Correct. So P, pressure, is equal to H rho G, right? So your H is the height of the liquid column. Like, again, that which liquid you use matters. Like accordingly, for example, I told you that, okay, what is the conversion from like say 1 ATM is how many mm of Hg?
So what is the question?
Pressure. I'm asking 1 ATM is equal to how many mm of Hg, like mercury?
29
760 mm. Sir.
Yes, right. So 1 ATM is 760 mm of Hg. Sorry, 760. right? So this we know how we derived, right? So we know the pressure, where, for example, would be 1 atm, right? And then I know height will be say in meters. This will be say in lead density. I know would be and density I know would be in
15.5
mass by
something.
volume. Sorry. 13.5, correct. So 13.5 will be 13.5. It will be kilogram per meter cube. Again, SI units, all SI units, right? And then for the G value, I know is 9.8. So that would be meter per meter. Sorry, a meter per second squared. Sorry, correct, right? So all these things, if you put in, right? So you'll be getting the height value, because this value, G value, we know rho will depend on the density of the liquid. That obviously we know, right? So 1 atm was found to be equal to 760 mm of Hg, or 76 centimeters of mercury, right? So obviously this 1 atm will be, this 1 atm will not be equal to 760 mm of, if it is some other liquid. Say if I talk in terms of water, is also another liquid. So that time it will not be equal to 760. It will be some other number. Why? Because you can see that the density will be varying. Density of liquid, density of mercury is different from density of water. Even though the G value is same, that is acceleration due to gravity is same, but your density value is different. So this number might not be same. Will not be same for water, right? Okay. And then what is the connection between mm of Hg and torr? What is the connection between mm of Hg?
mm of Hg is equal to 1 torr.
Yeah, exactly. So mm of Hg and torr are same, right? So 1 mm of Hg is equal to 1 torr, right? So, and one more last thing. So how will you convert atm to Pascal?
Multiply it with 10 power 5.
Correct, right? So 1 atm is 10 to the power 5 pascals, or 10 to the power 5 Newton per meter square, right? Okay, so these are the different units of pressure, and these are all the different conversions which you have to know, right? Okay, then we went on to see about volume, right? So volume, I told you that gases have a very special property, right? What is the special property regarding volume for gases?
Gas will occupy the whole volume. It depends on the volume of the container.
Yeah, like whatever volume you give it, right? Whatever volume you provide to the gas, it will occupy that entire volume. So as you said, yes, it depends on the vessel, right? If there's no vessel, right? So I can say that they assume the shape of this room, or like any particular imaginary boundary you can put, right? So anyways, so gases doesn't, like, that's why they say that gases doesn't have proper shape. They assume the shape of the container, right? And the volume, why is it so special, is because the volume, as such, the gas doesn't have any volume. The volume is definitely going to depend upon which container that gas is in, right? Okay, so that's about volume. And then we saw different units of volume also, right? Okay, what is the SI unit of volume?
Meter cube,
What is
sir.
yes, SI unit. So people will confuse between meter cube and liters. Liters are not the SI units. Meter cube is the SI unit for volume, right? Okay, so how will you go? So then we have centimeter cubes, then we have ml, liters. So these are the only 4 units we generally use for our calculations, right? So tell me, like a 1 centimeter cube is how many ml?
1 ml.
Yes, 1 centimeter cube is 1 ml, right? Okay, so then what is the conversion from meter cube to liters?
1 meter cube is 10 cube liter.
Yeah, 1000 liters, right? So 1 meter cube, right? 1 meter cube is 1000 liters, right? And there is actually one more unit which can be asked, if your school really want to test you, right? They can ask, or it may just generally asked in your competitive exams also. Like say it's decimeter cube, right? Say generally we have decimeter cube. So it's very simple. 1 decimeter cube is 1 liter. Very as simple as that, right? 1 centimeter cube is 1 ml, right? 1 decimeter cube is 1 liter, and 1 meter cube is 1000 liters. Okay, so So yeah, these are all the different what is that, volume units and their conversions, right? And then we went on to see your temperature, right? Temperature is very simple. Actually, I told you that we'll speak in depth about temperature in the next chapter. Next chapter, yeah, thermodynamics, right? So we'll be speaking there. But now, for now, what you have to know is it just talks about how hot, or it's a measure of how hot or how cold the body is, right? And generally, we use only two units for temperature, that is degree Celsius and Kelvin. And Kelvin is the SI unit of temperature, right? This you have to know, right? Whenever you substitute, so whenever a problem comes, right? Whenever a problem comes, they will specifically give the value only in degree Celsius. You should not substitute that value in the problem. You should convert it into Kelvin. There is no exception. In any problem for that matter, you have to convert degree Celsius into Kelvin and then only substitute the values. Only SI unit of temperature is accepted during the calculations. But for measurement, yes, we can use different units of temperatures. But for calculating purposes, right, definitely you have to use only Kelvin. Okay, so that's where we stopped last class, right? And then I told you in this class, we will be speaking about what are the, how one particular parameter is different, like say depend on the other one, right? So if I vary by volume, how the pressure is going to vary, how the temperature is going to vary, right? So all these are the things we're going to see in this class, right? So like we don't have to do much, right? Already all these things are studied by different scientists, and which are, I told you that these are given in forms of laws, right? Okay, so we'll see one by one, right? Cool. So first one is what is called as my Boyle's law. Okay, this is what I call, like this is the law, which is called as Boyle's law. The scientist's name is Robert Boyle, right? Okay, so what this law says, so this law talks about pressure and volume, right? Now please understand, for all the laws which you are going to see, right? So we will take two parameters which will be varying, right? And there will be two parameters which will be constant, right? So like I told you there are four parameters, that is pressure, volume, temperature, and number of moles, right? Amount, right? So in all the laws, like there will be, I think, Boyle's law, Charles' law, Cayley-Sachs law, Avogadro law, in all the four laws, right? So you have to make sure that there are two variables, that is two parameters are varying, and the other two are constants, right? Okay, so in this case, Boyle's law speaks about pressure and volume variables, right? Okay, so what this law says, please take down, if at all you're taking it down, like it's a statement which you have to take down, right? Okay, so it states that the pressure of the gas, it states that the pressure of the gas or
Sir, OR or AR, sir?
OR, right? So the pressure of the gas, OR, or pressure applied on the gas, pressure applied on the gas is inversely related or inversely proportional, is inversely proportional to the volume, is inversely proportional to the volume. Okay, so this is the statement. Okay, so if you just, oh yeah, like yes, I missed something. So is directly proportional to volume at constant temperature and number of moles. At constant
So you said
temperature.
inversely proportional, sir.
Yeah, sorry. It's inversely proportional to volume at constant temperature and number of moles. Okay, so the temperature. So I told you there should be two variables and two constants here. Temperature and number of moles are constant. Volume and pressure are varying. Right? Okay. So if I put it mathematically, if you just study this statement, if you want to put it mathematically, it's very simple, right? So pressure. Okay, now before mathematically, we'll analyze the statement, right? So we'll try to bring in some real life examples. Not real life examples. I can show you some arrangement, right? So where you can actually, I'll actually be able to give you proof that this statement is correct, right? Okay, so let me take a case, right? Right, say I have piston. This is a piston, and inside this,
What is
sorry.
that piston?
Okay, so you don't know what is a piston, right? Okay, this is a vessel. Okay, so this is like a pump. I can push it up and down. Like this is the handle, right? So I'll be able to push it up and down. That's what is a piston basically.
Okay, sir.
Okay, fine. So what I was telling, so yeah, I have a piston arrangement. Inside that I have some gas, right? Okay. So now this is an equilibrium. Okay, what do you mean by equilibrium? Right. So now, okay, now I'll ask you a question here, right? Now assume that this piston is stationary. I'm not doing anything, right? I'm not doing anything. I just have a gas, I have a piston, and it is standing still. Okay. So I'm just giving you this much information. Can you tell me what is the pressure of the gas?
Sir, can you say the question again, sir?
0, sir.
And in this arrangement, so there is some gas here, right? So I'm asking, what is the pressure of this gas? What is the value? Any guesses?
Sir, I'm guessing 0.
0. Oh, wait. So when will you have zero pressure, people? At what? There is one term for that. What is the term? Zero pressure. Okay, first I'll answer that question. Like what? Like first you answer this question. What is the term, or what is the area which is having zero pressure? What is it called as?
Vacuum, sir.
Exactly, right? So it's vacuum, VACCUM, right? So vacuum is the, I would say, if I say that this area has vacuum, that means in that particular area, I have no pressure, zero pressure, right? But again, that is very, very difficult to like exactly get zero, right? It's very, very difficult. Sorry?
100.
So you're telling here it is 100?
Yes, sir.
100
Oh, no, sir.
what? See, in chemistry or physics or any science subject, when you tell a number, that too, if it has a unit, you should always tell it in unit, 100 bar or 100 mm of Hg. Like we know we have so many units, right? Right. The answer is wrong, apparently. Like whatever the unit you take, that the 100 is not the answer. But still, when you tell the answer, please tell the unit also. Okay. Any other answers?
10 to the power
Depend on
5.
the density. It will depend on
Sorry?
density and height, no, sir.
It will depend on density
Without
and
knowing it, we
height.
can't find exact value.
No, we can find. There is a way. So someone said 10 power 5. 10 power 5 what, ma'am? Which unit?
Pascal, sir.
Okay, ma'am. Why did you say that? Or it was just a guess?
Google.
Yes, sir. Just a guess, sir.
Okay, fine. Actually, your guess is correct, right? It is actually 10 to the power 5 Pascal, or I can say that it is 1 atmospheric pressure, right? So please understand, people, right? So here I have atmospheric gases exerting pressure on the surface of the piston, isn't it? Right?
Yes, sir.
Okay. And I know that these gas particles are also exerting pressure from the downward regions. Yes?
Yes,
Right?
sir.
Area is same, right? So in this, if I say P is equal to F by A, right? Say these, what is that? There is some force from downward side, there is some force from upward side, and the area is constant because there is the same piston, right? So obviously, like if this piston has to stay at equilibrium, if this piston is not moving, obviously I can say that the forces are balancing. Correct? The downward force is cancelled
Yes,
or
sir.
nullified by the upward force. Correct? And if the area is same, can I say that the pressure of the gas is equal to the pressure of the atmosphere? Obviously, because
Yes.
the area is same. Because the force is same, the area is same. Definitely the pressure. Why I'm telling force is same is because this piston is not moving. right? So obviously the pressure of the gas, which is exerting on the piston, and the pressure applied by the atmosphere on the piston are same. That's why it's staying still, right? So obviously I can say that the pressure of the gas is equal to the atmospheric pressure. But if I have closed this was not open. This is a closed vessel. At that time, we will not be able to say that. Why? Because we know that, like, if it is not open to atmosphere, we cannot say there will be some gases. Obviously, I can say that if it is closed, there will be some gases. It is not. If it is vacuum, the pressure is zero. That we know. If this area I'm telling, right? But if it's not vacuum, I will have some gas that will be exerting some pressure, and that pressure will be equal to the pressure of the gas if it is closed, right? But if it is open, no, there is no this thing. If it is open to the atmosphere, right? So definitely the pressure of the gas will be equal to the pressure of the atmosphere. I know what is the pressure of the atmosphere is basically going to be 1 atm at sea level, right? Yeah, logical question would be, sir, you didn't give me any temperature. Yes, temperature I should have given. Room temperature should have been, like, is ideally assumed normal conditions, 25 degrees Celsius. Okay, so everybody understood how this, in this case, the pressure of the gas is equal to 1 atmospheric pressure.
Yes, sir.
Okay, fine. So why did I tell all this? Okay, so because I want to explain you Boyle's law, right? So we understood that in this case, right, so the pressure of the gas is equal to the atmospheric pressure. Okay, now what I'm going to do is that I am going to add some 5 kg mass onto this piston. Okay, I'm going to add a 5 kg mass onto this piston. What do you think will happen?
The mass might sink, sir.
Mass might. What do you mean by sink?
Sorry, sir. It was a liquid. Sorry.
Sorry?
For a minute, I thought it's a liquid. I forgot it's a gas, sir.
No. It's a solid. It's just a mass. Like, say some weights, right? We use for measuring
Yes,
in your
sir.
old days. We say, I don't know, Tamil tarasu. So whether we use weights, weight balance. Okay, in English, weight
Yes,
balance.
sir.
So anyways, so what do you think will happen if I place this weight?
Pressure increases as this thing goes down, sir.
Okay.
It will
So
fall to the
correct.
bottom.
So obviously now here the atmospheric pressure was only there. Now because of this 5 kg mass, so extra pressure is there. So now what will happen? So because of the extra pressure, what will happen?
The below part will get compressed.
Very simple, right? Now the piston, this piston can move up and down. I already told you, right? So what will happen now? The moment I place this
Piston will
piston,
go
it would have come down. That's it. It would have come down again. Like it will come down. So is it like, say, if I just put this 5 kg mass, this can come here and then hit the bottom? Is it possible?
It can be, no, sir.
Yes,
So
sir,
what do
it
you
is
say?
possible in some cases.
Okay, so if you say this is possible, right? Obviously that means the gas should not be there. This is basically zero volume, correct? So how can I attain zero volume? I can have zero volume only and I have nothing, right? So this hitting the bottom is not possible. This is possible if there is a way in this that the gases can escape out of this vessel. Yes, that can
It's
happen.
not closed, no, sir. Is it closed?
It is closed in the sense the piston covers the entire area, right?
Oh, okay,
Above
sir.
the piston,
Then,
it's open.
and then yes, I
Right.
understood.
So, like I'm telling that this particularly cannot come down and hit the bottom. As such.
Understood,
Definitely
sir.
some residue volume which will be there. If you apply so much pressure, what can happen is something called as liquefaction. Like liquefaction is the process where I convert a gas to a liquid by increasing the pressure. So anyways, we'll be seeing this case again in the last end of this chapter, like compressing a gas and converting into a liquid, right? So that one we'll see later. So what now I'm telling is, so you can understand that when I place this 5 kg mass, right? So the piston goes down, right? So now the question is, until what time or what is the, like, so obviously if we understood it cannot hit the bottom, so it has to stop at some point. Correct, it has to stop at some point. So at that time, how would I put it? At that time, can you calculate the pressure of the gas? Say I give that the area of the piston is say some x meter squared. Okay, the area of the piston is some meter squared, x meter squared, some number. So if I know it's a 5 kg mass, and if the area of the piston is this much, can I calculate the pressure at this time? Now it is not equal to 1 atm, obviously, because it is not only going to be open to atmosphere. It is, I would say, it is even negligible. The atmospheric pressure is even negligible when compared to the pressure applied by this 5 kg mass, right? So now can I calculate the pressure of the gas at this moment? If yes, how will you calculate? What do you mean by weight? Sorry? Okay, what is the formula for weight?
mg.
W is equal
mg.
to mg. Okay. So is this a force?
Yes, sir. A force of an
Force due
object.
to exactly. So mass pulled by the gravity, mass into the acceleration. Instead of acceleration, F is equal to basically ma. Right. Now instead of A, if I put G, it becomes weight. Right. So now what is pressure? Pressure is force by area. Right. And force is here in this case is what? The force exerted by the 5 kg mass, and that is the force basically, m into g. So I would say force, how will I calculate? The mass is weight, that is F is equal to ma. So I will be saying that it is 5 into 9.8. 5 is the mass of the block, 9.8 is the g value, and g divided by area, which I gave you, is x, whatever the number is. So I'll be able to calculate.
Yes.
Right, everybody understood? At any given point, right, if the piston stays still, right, whatever is the pressure from the bottom is always equal to the pressure exerted by the gas. Only then
49
the piston. Sorry?
49 by x, sir.
Yeah, 49 by x. Yeah, correct. Right. So yes. So this is what. So what? Okay. So the very essence of it is to understand the statement which is given to you for Boyle's law. Pressure, like say the pressure is inversely related to the volume. That means if I increase pressure, yes, I am increasing pressure, and what do you see? The volume is decreasing, right? So the pressure which you speak can be the external pressure, right? Or it can be the internal pressure. Internal pressure in the sense the pressure of the gas, right? So either way, any pressure you speak, either you exert more pressure, or if the gas exerts more pressure, the volume will decrease. Okay, so that's what is the loss is, right? And we have proved it with the help of an experiment also, right? Okay, so we'll see what happens mathematically, right? So I will say that pressure is inversely proportional to volume, right? So I can say if I remove the proportionality sign and if I put a constant, so I can say that P is equal to K by V, right? Or I can say that PV is a constant, right? Or I can say that P1V1 equal to P2V2, which is a constant, or say PNVN, I can keep on going, right? So multiplication of pressure and volume at any particular point, right? The multiplication value will be same at all the points.
So
Right.
what is the
So what
alphabet for constant?
Oh, this is K, but doesn't matter. It can be any letter. So we generally use K for constants, right? So P1V1 equal to P2V2. So this particular thing, like based on this, we can have problems also, right? So we will do problems, but not today, I guess, right? We'll see some loss and then we'll do some problems. Okay, so you can see pressure is inversely related to volume, right? So I can write P1V1 equal to P2V2 is equal to P3V3, so on and so forth is constant. Okay, so now what we'll do is we'll try to plot a graph, right? between pressure and volume, and we'll see how the graph looks. Okay, right? So this you have taken down. This is very, very important, right? Like questions will come from this Boyle's law directly. Again, like this is all applicable. All this is applicable at constant temperature and number of moles. Again, if temperature is varying and you have pressure and volume varying, no, like we will not be able to generalize that pressure will always be directly inversely related to volume. Only if the temperature is not changing at constant temperature and number of moles. This is true. So even in the previous case, I told you the amount of gas is not changing because there is no way that the gas can escape, right? So the number of molecules, the number of moles, everything is constant in the previous case, and now obviously the temperature also was constant, right? Okay, so we'll see. Now what we're going to do is we're going to plot a graph between pressure and volume and different modifications of that graph. We'll see. Okay, so all these equations are going to help you, right? But I'm going to rub it now. Okay, so we are going to plot a graph between pressure and volume. Okay, right. So we know as pressure increases, the volume has to decrease, right? Or say as volume increases, the pressure has to decrease because it's inversely related, right? So generally for a inversely, so if I have y is equal to 1 by x, these kind of curves, right? Y is equal to 1 by x, because that's what we saw. P is equal to k by v, and k will some number other than 1, or it may be equal to 1 also, right? So this kind of graphs, you'll be studying it in mathematics, right? So but depending on the equations, right? Depending on the equations, you'll be able to predict how the graph will look, right? So whenever you have this kind of equations, you will be getting something called as a rectangular hyperbola, right? The shape of the curve in the graph is called as a rectangular hyperbola. You don't have to remember it, right? Anyways, you'll study in mathematics. But the shape of the graph, even if you don't remember the name, the shape of the graph which I'm going to draw should be known, right? And you don't have to memorize the graph. It's very, very simple. The graph is going to be something like this, right? So how did I get this graph? You can see as the pressure is increasing, the volume is actually decreasing. Or say as the volume is increasing, you can see that the pressure is decreasing, right? So that's how we get this curve. And this particular curve will never ever meet the x-axis because the volume cannot be 0, right? And obviously even this pressure, okay, if we wanted to meet y-axis, again it will not be meeting because that means the pressure of the gas is 0. I mean, like again, it means vacuum. That's again not possible. So this will keep on going, this will keep on going, and this is how the graph looks for P versus V, right? Fine. This graph we understood, right? Now what if I plot a graph between P versus 1 by V? How do you think the graph looks?
Straight, sir.
Yes, straight graph.
Yes, it's a straight line. This okay. Okay, where will it start from? Will it have any intercept is what I'm asking. Y intercept, X intercept. Will it have any, or will it start from somewhere else?
It won't intersect, sir.
So it will start from
From origin, sir.
yes, right. That's the answer. So it will start from origin. Okay, now how will you how am I telling all this? It's very simple. If we just look at this equation, I have P is equal to K into 1 by V. I can write it like this, right? And in the y-axis, what I have? In the y-axis, I have my P, right? And in the x-axis, I have my 1 by V, right? And say this K, it can be any constant. I can just write it as M. So what do you have? Y is equal to mx. What does this equation tells you? This equation tells you that it is going to be a straight line, right? Where M is the slope, right? And X and Y are the axis points, like the coordinates, Correct. So you will have, so you can see 1 by v is what is my x and p is what is my y, right? So so how will you understand whether it is going to start from origin or not, right? So generally we say that y is, if it's of the form y is equal to mx plus c, right? So this c is what is called as my intercept, right? So like the graph will be a little different then. For example, here the graph, now here you can see y is equal to only mx is there. Correct. There, like, because p is equal to k into 1 by v, right? So there is no intercept. That means the graph is going to be a straight line passing through the origin, right? If I have an intercept, like say if this is of the equation, this is my y, this is my x, right? So if I have an intercept of c, some constant, you will have the graph like this. See, it is not starting from 0. It is not starting from origin. It is having some value. So what I'm trying to tell you is, if I put the x value as 0, if I put the x value as 0, you can see this entire term will go, and I have 1d y is equal to c. So this is my c value here, right? So even if x is 0, y is not 0. That it has some value. That's why it starts starting at the origin. It is starting at some point in the y-axis. But in this case, it will pass through origin because I just have y is equal to mx. The c is 0. So when x is 0, what is that? Y is also 0. Okay, right? So these two graphs, very, very important. Now let me see, if you are really smart, you are going to answer the question. Like, I'm going to give you one more graph and you are going to answer it. See, the questions can come from graphs also. Please be very careful. Okay. So I have p into v in the y-axis, and say I plot it with volume. Tell me how the graph looks. See what is Boyle's law. See what is the mathematical form says, and then you're going to answer this question.
Will there not be a graph?
No, it's not like that. You are going to have a graph.
So still, is it a straight line, sir?
Okay, ma'am. Yeah, it is correct. It is a straight line. Okay. How the straight line will be?
Up to down, sir.
Up to down.
Telling like this.
Uh,
Are you telling like this?
yes, sir.
No. Guys,
It will be
mathematically parallel to
y-axis.
like this.
Yes, sir. Something like that.
Okay. I see that almost you're getting there, but the graph is not like this. The graph is like this. It is parallel to x-axis. Okay. Now, how did I arrive at this? Very, very simple. Now, mathematical form of Boyle's law says what? PV is constant, so it is some constant K, right? So even if you're going to change the volume, the pressure is going to change accordingly, so that this PV value is always a constant. P1 V1 will be equal to P2 V2 will be equal to P3 V3. Say if it is say V1, V2, V3, whatever the volume is, the pressure would have changed accordingly, making sure that this term PV is constant, right? So whatever the value of PV, say this is the K value, it is not going to change even though the volume is changing, because according to Boyle's law, the multiplication of, or say the product of pressure and volume is always constant, right? So everybody understood how this graph came parallel to x-axis?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, cool. Right. So if I want to make it a little more tough, okay, these are sufficient, right? So if I want to make it a little more tough, I can ask you this question also. If I have log of P versus log of V, how the graph looks or how the graph will look. Do you know how log works? Logarithmic things, you know how it works?
A to the power of B is equal to C, and then log wait, sir.
Yeah, so like basically I can say that your exponential and your log are inverse functions. Right?
Yes.
So like just like sine and sine inverse, I'll have log and exponential, like they are inverse functions. Okay, so anyways, like that level we don't have to know. You just have to know how can do operations, like not your, like say cutting and opening up, that operation, mathematical operations, how you can do in what is that, with logs, you have to understand, right? So can you predict, like say, like you have to start with this PV, or P is equal to K into 1 by V, or you can write it as PV is equal to K, right? And you have to start from this, and then if you just apply log, what kind of graph you'll get, you'll be able to predict. Do you know how it works? So if I take log on both sides, right? So log of PV, if I can write as log of K, because the values are same, even the logarithmic values are same, right? Okay, so now if I have log of some xy, how I can write it? Did you see? You should have definitely seen it in physics. Did you see, or like some way mathematics?
I don't think we've seen log yet, sir.
Sir,
Oh.
till now we did integrations. Not
We did
log.
only
Yes, sir.
differentiation and integration.
So it's actually important, right? I will teach you, okay? Not the exact mathematics, but whatever is required for chemistry, that I'll teach you. Okay, logarithms, right? Okay. So we'll answer this question very quickly. Hold your thoughts. Okay. So as I told you, log and exponential are inverse functions. Okay. So generally, if I'll write it like this: log to the base a, log a to the base b. This is how I generally represent log. Log has two components, right? So one is this, which is the log of that value, and this b, which I write here, is what is called as base value. Okay, this b is what is my base value. Okay, so I have two components here. Generally, like the base value, I'll tell you, like we're going to have only two types of bases. Like it's very simple. Anyways, so log of a to the base b, we call it, right? Say if this is equal to some c, okay, this is some value, this is equal to some c, right? Now, how can I have relationship between a, b, c, if you ask me, right? How can I have relationship between a, b, and c? It's very, very simple, right? How I
A
can
to
write
the
it
power of
is
C is equal to B.
a to the power of,
C is equal to B.
no. It is going to be, so I'll tell you how, right? So you have the base, right? So bring the base here into the opposite side and make the other thing which is already there in the power and remove the log. So how will I write it? Is a is equal to b power c. This is how I can write it. Okay, a, which is here, let it be here. Bring the b here and make c go to the power and remove the log. Right? Or if you want to see the other way, right? So if I take log on both sides, I have I have a is equal to b power c, some equation, right? Now if I apply log on both sides, okay, so what will I be getting? I'll be getting log a is equal to log of b power c, right? Now you can write this particular thing as, you can always write b power c. If you you can bring the c this side, right? So you can write log a is equal to, you bring the c here, c log b. Exactly the opposite of whatever we did here, right? Exactly opposite of whatever we did here. Okay. So okay. Anyways, like what I'm trying to tell you, there are only two operations you need to you need to know. Okay. So what we need to know is, if I have log of x to the power y, this is the first operation, right? Whenever you have log of x to the power y, some power is there, right? You can write it as, you can bring this y this side and write it as y log x. This is same, right? For example, if I have log of 4, right? How can I write log of 4? Log of 4, I can write it as log 2 squared. This I can write it as 2 log 2. I told you the power can come before the log. So the 2 come before. So I can write log 4 as 2 log 2.
Sir, if it is log 16 means we can write 4 log 2, sir.
Correct. Right? A log 16, if I can write it as log of 4 squared. So now this 2 comes here. So I can write it as 2 log 4. Or if I write it in terms of 2 power 4, this can also be written as 2 power 4. This can be written as 4 log 2.
Okay, sir. Yes,
Right?
yes,
So this
yes.
is one of the operations you need to know. Whenever I have the power, bring it before the log. Okay, right. Now other operation, which is basically going to answer the question here, right? This is going to answer the question here, is going to be when you have log of 2 multiplication, say log of x into y. Log of x into y. If you have this, right, you can write it as log of x plus log of y. So whenever you bring inside the log, the multiplication becomes addition, right? So log
Sir,
of
what is
xy.
log of 7, sir?
Log of
7 means you have to write 7 per 1, sir.
Correct. I'll tell you. So okay, you are right. Basically, log of 6 I have. Okay. Now, how can I write log 6? I can write as log of 2 into 3. Correct. Right.
Yes, sir.
So now I can write log of 2 into 3 as log 2 plus log 3. So you can see log of xy is equal to log x plus log 3.
Sir, what is the log 2, sir? What is that log 2, sir?
It's a number. It's a number. It's a number. Did you start using log books for
No, sir.
calculations? Did they teach you
No,
how
Not
to
yet,
use
sir.
log?
No, sir. Still
No,
not
sir.
teach, sir.
Okay, so they will teach you to use log books. Like I cannot teach you because I don't think you have the log books, and even if you have, teaching it now will be difficult. But anyways, we will try to have some session. I'll tell you how to use the log books, right? Okay, but for now, please understand that log is actually a number. Log of 2 is a number, just like 2 is a number. Log is an operation. Say how you have sine of 90 is how much? Sine of 90 is 1. 1 only, right? 1, right? So sine of 90 is 1. So sine is an operator, mathematical operator. Just like that, log is also an operator. So sine of some number is equal to some number. So log of some number is equal to some other number. Okay. So that number, say you are asking, if you ask me, what is the log 2 value, sir? You must actually not ask that question, because all the log values, log of that value is not only that important. That base is also important. I told you I have log a to the base b. That is very important, right? So if you don't ask me what is the base, then I will not be able to answer that question.
Sir, then
Right? So
if it is 1, sir, the base is 1,
I'll tell
sir.
you. Coming to that. So now you have, generally we use only 2 types of base, like 2 numbers of base, basically, right? So I have something called as log to the base e, right? Log to the base e. E value is around 2.303, I guess. Yeah, it should be around that value, right? So log to the base e, or I have log to the base 10, right? And if generally, and this log to the base e generally will be represented by ln, ln, we call that, right? And log to the base 10 will generally be represented as nt log. So if nothing is written in the base, that means by default it is 10, right? And if nothing is written and just ln is written, ln 2, I write instead of log 2, if I write ln 2, that means the base is e. Okay. Like again, it's simple. If I just tell it like this, say log of 10 squared, right? Log of 10 squared is some x value. Right? Log of 10 squared is some x value, right? So assume that the base value is 10. Okay, assume that the base value is 10. Okay, now please understand another. Okay, now like there are getting too many things into the picture. Just first we'll concentrate on this, right? So whenever you have log of xy, it can be written as log x plus log y. So I gave you the example. Log of 6 can be written as log of 2 into 3. So I can write it as log 2 plus log 3. Another operation I told you, whenever you have log of x power y, I can write it as y into log x. So these two operations you understand. Okay. Now other than that, the third operation is whenever you have log a to the base a, if the value, if the above value and the base value is same for a log, right, that will always be equal to 1. That will always be equal to 1, right? So 3 things you have to remember. When I have powers, right, when I have a log of some multiplication, and when I have the base and the above value to be same, that is log of a to the base a will always be equal to 1. Okay. You will get a lot of insight about this log. I think you will not study about logs, say the mathematical graphs and exact the mathematics is required. We will not study in mathematics actually, right? It is not there in your syllabus. But if you go for any competitive exam, right, say JEE, right, you will be requiring logs, and the syllabus has a logarithm. The mathematics problem can come from logs itself. Like if you go for competitive exam, but as a school, no, they're not going to ask you. And as far as 11th is concerned, you will be using logarithms in thermodynamics somewhere, and in 12th, you extensively use log calculations. When I go for chapters like electrochemistry and all that, right? So you use log a lot of times there. So knowing the operations, like not even though you don't know the exact mathematics out of this, but doing the simple things about log helps a lot of times. Okay, so like for example, if I want to answer this question, that is log to say if I just forget square, right? So I told you log to the base, log a to the base a is always equal to 1. So log 10 to the base 10 is always 1. In this case, both the base and the above value are same. So log 10 to the base 10 is equal to 1. Okay, so if that's the case, if I ask you again, if I put a square, log of 10 squared, I ask you, what is the value of log of 10 squared?
2 log 10.
So what is the value?
2 log 10.
So
2.
what is the value?
2.
Correct. All right. So that's now I told you. Now when I don't tell you anything, the base is 10, right? But by default it is 10. So now whenever you have power, I can bring this here. So I can write it as 2 log 10. And again, I don't have to mention the power base every time, right? So it's 2 log 10, and just now we saw log 10 value is 1. So the 2 log 10 value is 2, or say I can say that log of 10 squared value is 2.
Sir, if log's base is n, what will happen, sir? Instead of n,
Then,
sir, what will happen?
then the value, there will be some value. It will not be 1.
Okay, sir.
It will be some other value. That's it. Right? Okay, so these are the things which you have to remember about your logarithms, right? So now when I, like all this we did just to answer the question of how to get the graph, right? Hope you got it. Anyways, we'll discuss again now that particular thing. I'm asking, I have log of t versus log of v, how the graph looks. Okay, so with the knowledge which you have, can you tell me how it looks? PV is k, some constant. You tell me how the graph will look. Apply log on both sides.
Wait.
Okay, straight line, right? What is the intercept? Do you have an intercept first?
Intercept means?
Now only I told it, it's c value. Y is equal to mx plus c. That c is what is my intercept.
Oh, sir.
Do you have an intercept?
Sir, I think no, sir.
That means you say that the graph is going to start with origin?
Yes, sir. From origin it will start, sir.
No.
Sir, both are constant only, no, sir. Then from origin only it will start, no, sir.
So let me do it. Or anybody have any answers you want to give me? guys? Any other answer you want to give me? So this is how the graph looks. It starts from here. It looks like this. Okay. So assume that nobody has answers. So let me do it. So if I'll apply log on both sides, log of PV is equal to log of K.
The log P is the intercept, sir.
Log
Log P is the intercept, sir.
log P, how it will be intercept? Already log P is in the y-axis. Log V is in the x-axis. How it can be intercept? Right. Anyways, so let me do it here. So now this is a multiplication. Correct? Log of T into V. I told you, you can just spread it out and write it as addition. So I can write it as log T plus log V is some log K. Right? So now I have, let me bring the log V that side. Okay, let me bring the log V that side. So I can write log P is equal to log, okay, I'll write like this. I have minus log X plus log K, no problem, right? Minus log X, so this becomes, not log X, I'm sorry, log of V. Okay, I have this log V, got it here. So I have minus log V. Okay, now it's very simple to understand, right? So you can see that log of P is in the y-axis, right? And log V is in the x-axis. Even though it's negative, I can just see log V is in the x-axis, right? So now this is of the form, can I tell that this is of the form y is equal to mx plus c? And if I just compare these two equations, what is m? M is the slope, correct? M is the slope. How many of you didn't know this? How many of you didn't know that m is slope? Was there anyone? Okay, fine. So everybody knows what is. Sorry?
I didn't know.
Oh my god. Slope of a line, you don't know what is it? Okay, so look at this. If I have a straight line, any line, okay, so the slope m can be calculated as y2 minus y1 by x2 minus x1. So say,
And this I know, sir.
this is what is slope. That's what is m.
That's it, sir.
Right.
Okay, sir.
Yeah, that's it. That's what is my m value. Okay, so this is my slope. So the slope tells me how slant the line would be. Say for different slopes can be, say this is one line. Okay, I would say this is one line. This is one line. So you can see the angle it makes with the x-axis. The angle it makes with the x-axis, that will be different, and that's what is written by the slope, right? So in another words, you can calculate slope like this, or if you know the theta value, if you know what angle it makes with the x-axis, right? So this m can also be equal to tan of theta. So this theta value, if you know, and if it is a tan value, right? So that theta, tan theta, is what is my slope, right? So anyways, so now you can understand this, like from this. Okay, so if I can write it as y is equal to mx plus c, what is the m value from here if I compare these two equations?
-1,
If I
sir.
compare this, yes, m is -1. What is the intercept value?
Oh, M is equal to minus 1, sir.
So you can see my log of p is y, right? And x is what? X is log v, correct? So before my x I have m, and in this case before my x I have
Minus. Log.
-1.
Minus log.
Right, so that's why I say m is -1. -1 into x.
Okay, sir.
Understood?
So here you took the value of log as, sir, here you took the value of log as 1, sir.
Here I took the value of log as 1. No, I took the slope value as 1.
Oh, okay, sir.
Now
Why
log
is it-
log v stays log.
Why you took the slope
Sorry?
value as 1, sir? Why you took the slope value of 1 as 1, sir?
That's what I'm comparing these two equations.
Okay, sir.
So here this is my y and this is my y, and log v is my x. This is my x. So if I just compare y is equal to mx, y is equal to mx, if I compare, this should be what? If this is m into log v, what is the m value? M value is -1.
Okay, sir. Okay, sir. Okay, sir.
Right? Cool. So now if I compare again the two equations, what is the c value?
log k.
Log k.
Yeah, correct. Right. So C value is log of k. Okay. So now you can easily predict the graph, right? So now what you have to understand is, people, right? So whenever you have a negative slope for a straight line, right? So whenever I say, for example, for a line, it is minus some minus one. On this case, it's minus one. In this case, it's like that. So it's very simple. You should, like, the graph should always be like this, right? And whenever you have a positive slope, the graph should always point up, right? Whenever you have a negative slope, it should always point down. You can, if you are really confused about it, put some random values and check, right? Say y is equal to minus x, put 0 0, and if I say y is 1, x is minus 1, and y is 2, x is minus 2. If you plot the graph, you will get the graph like this only. Okay, this is negative slope, this is your positive slope. Okay,
Okay.
right. Right. So now how the graph is going to look? So definitely it is going to be a straight line, because it follows of the form y is equal to mx plus c, and it is going to have a negative slope, right? And one more thing is, I have the intercept to be equal to log of k. The graph is going to look like this, right? So this value which I have here, the intercept, is my log of k, and the slope of this line is minus 1. We just saw the slope of this line is minus 1.
Okay, sir.
Okay. So this is how log of t versus log of v graph will look.
Okay, sir.
So this is about Boyle's law. Okay. So we have 3 more laws to look at, and we have to do a lot of problems, right? So yes, and that's it for today, right? So tomorrow's class we'll see more laws.
Okay, sir.
Okay. Yeah. Thank you so
Thank
much.
you,
Nick.
sir.
Thank you, sir.
Bye
Thank you,
bye.
sir.
Thank you.
Thank you, sir.